All right, we're continuing on with Chapter 24. This is the same problem we were looking at last time. Resting pulse rates for a random sample of 26 smokers had a mean of 80 beats per minute and a standard deviation of 5 beats per minute. Among the 32 randomly chosen non-smokers, the mean and standard deviation were 74 beats per minute and 6 beats per minute. Both sets of data were roughly symmetric and had no outliers. So last time we proved that the two groups were different. Okay, just to remind you, that's what we did. Right, here was our hypotheses. Right, the alternative, the thing we're proving, was that they were not the same. They were different. And so that's what we've shown in our hypothesis test. We said there is evidence that there is a difference in the average heart rates between the smokers and non-smokers. So the question might become, how big of a difference? And that's what confidence intervals can show us. So we're going to create a 95% confidence interval for the difference in mean heart rates for these two groups. So this is going to show us, like, how big is the difference. I know what you're thinking. You're thinking, Ms. Curtis, the difference obviously is a difference of 6, or an average of 6. But remember, it's a sample, so there's some possibility for a fluctuation. That's why we're creating a confidence interval. So the first thing we do in a confidence interval is we check our conditions. I'm going to remind you what they are. We verify that we have a random sample. We confirm that both groups are nearly normal. Remember, that means if I had data, I would have 2 histograms, one for the smokers, one for the non-smokers. And I verify that my groups are independent. This is so important. You cannot do Chapter 24 unless you have independent groups. What do I mean by independent? I mean the person in Group 1 does not influence the person in Group 2 in any way. So I'll just remind you, we checked these last time. We verified both groups were randomly selected. It said that in the story problem. We talked about how we could not make histograms, so instead we commented that the story problem gave us an out. It said they were symmetric, no outliers. That's nearly normal. And then we talked about the fact that the groups are independent because the smokers are not affected by the non-smokers and vice versa. So our conditions are checked. We're good to go. For your information, we're completing what is called a 2-sample t-test. T interval, because we're doing a confidence interval. 2-sample, why? Because we have 2 different samples, 2 groups. T, remember when we're talking about means, we always use T. And interval for confidence interval. Not a Z, that's an I. Okay, so we check our conditions, and then we move on to the mechanics. I put this formula here to remind you that this is what things looked like in Chapter 23. We had our X bar, kind of like p hat. This is our sample mean. Just like any other confidence interval, we plus or minus some t star, and then we had this little subscript for that degrees of freedom. And then once again, we had a standard error here where we take our sample standard deviation divided by square root of n. 2 samples look very similar. I hope you'll notice the similarities. I put them together hoping you would notice similarities. This time I have 2 different X bars. Why? Because I'm studying their difference. That's why I subtract them. I'm studying their difference. I would subscript 1 S for smokers and NS for non-smokers. 2 groups. I still have a T star. We're going to talk about the degrees of freedom. And then again, I multiply by the standard error. I hope this formula looks familiar. It should look an awful lot like this one we talked about last time. Notice that I did not use sigma. I used S. Sigma is the truth. It's a parameter. I don't know it. So I switch it out and substitute it for a statistic. A guess. That's what we see. Of course, you don't actually have to write out this whole formula. What I do want you to write out, I'm going to switch it to green so I can be really specific. This is what you would write to show your work. Don't write the formula. Write the formula with the numbers plugged in. So I'm going to put my mean for the smokers that was 80. That's given in the problem. I subtract the mean for the non-smokers, so 74, plus or minus some t-star value. I'm going to leave myself a spot to remember. I need to go back and write in that degrees of freedom. That's important. This formula is really gross and disgusting, so we're going to get the value from our calculator. And then I put in my standard deviation was 5. Notice it's squared over my sample size of 26 plus my standard deviation 6 squared divided by 32. Yes, you need to make sure you match. Whatever you use on the top, same group on the bottom. So for me, this is the smokers. And then the second set of fractions is my non-smokers. So make sure you match the right standard deviation with the right sample size. Okay, and then all I'm going to do is wait to copy my interval down from the calculator. I'm going to save myself a lot of agony and let my calculator do the hard work. We're doing the thinking that's involved, but we're letting the calculator do the boring computations. So as you might imagine, we're going to go to stat, we're going to go to test, and I told you it's a 2-sample t interval, so I'm going to have to scroll down until I find the intervals. 2-sample z, no, I want 2-sample t interval. Select that one. We don't have data, so I am going to specify the statistics. My x bar was 80 with a standard deviation of 5, a sample size of 26. And then my next one had a mean of 74, a standard deviation of 6, and a sample size of 32. Confidence level, yes, I asked for 95%. We always say no on pooled for t's. Never pool for t's. And I'll go ahead and calculate. So here's my answer that I'm going to copy. 3.10, maybe 3.11, let's round that off. 3.11, comma, 8.89. 3.11, 8.89. All right, so that's my interval. This is measuring the difference in their average pulse rates. So I can write a sentence about that. I am 95% confident that the mean heart rate for smokers is between, well, I said 3.11 and 8.89, I better put a unit there, beats per minute, higher than the mean heart rate for non-smokers. Why did I say higher? Remember I did smokers minus non-smokers? That means positive values indicate that this one is bigger. So that's why I said higher. Okay, just an explanation there. Be really careful how you word these. Notice I said the average, the mean heart rate for the smokers is such and such higher than the mean heart rate for the non-smokers. It can be very easy to choose words that make your conclusion no longer true. So I'm just going to encourage you to be really careful. Even when I write these conclusions, I have to stop and really slow down and think about what I'm writing. So be cautious and practice, and of course ask questions. Almost forgot to mention, but really important, please use caution. I'll say it one more time. In order to use the techniques we've learned in this chapter, I'm talking chapter 24, the two groups have to be independent. If they're not independent, then we move on to chapter 25. But for now, if they're not independent, you're kind of off the hook. You can't finish it, at least not until the next chapter.